So good day everyone. My name is Kate Angie Sumugod, and in today's video, I will discuss about the electromotive force and circuits. But before we start on the main topic, let's see first the overview of this lesson. So electromotive force is the energy per unit charge imparted by an energy source such as a battery or generator. So it drives electric current through a circuit. So EMF is measured in volts and is represented by the symbol E. So circuits also a closed loops of electrical components through which current flows. So they require a power source like the battery to generate EMF. So conductors carries the current and the loads like our bulbs or generators consumes the energy released by the uh, um, energy source. So understanding the components and their interaction is essential for analyzing and designing the circuits. Electromotive force or EMF is often abbreviated as EMF, and it is a fundamental concept in electric circuits. So it represents the energy supplied by a source, like the battery or generator, as what I have said earlier. This energy allows charges to move through the circuit, creating an electric current. So imagine a water fountain. The pump in the fountain does work to move the water uphill against the force of the gravity. So this work done by the pump is analogous to the energy provided by an EMF source. So imagine yung water fountain as the EMF. So in an electric circuit, the EMF source does work to move charges from a regions of lower potential to a region of higher potential. So the work is done um, against the electrostatic force, which naturally pushes charges from higher potential to lower potential. So EMF is generated by various devices and processes, including electrochemical cells. So these electrochemical cells, like batteries, converts chemical energy into electrical energy through chemical reactions occurring at the electrodes. So other examples are generators. So this device utilize mechanical energy typically from rotating cells in a magnetic field to produce the electric energy. So solar cells also, the photovoltaic cells converts light energy into electrical energy through the photoelectric effects. So other examples are fuel cells, thermocouples that generates chemical energy into electrical energy. So what is the relationship of EMF and electric current? So when we say EMF, it is directly related to the flow of electric current in a circuit. So when a source of EMF is connected to a circuit, it creates an electric field that pushes electrons through the conductive material. So the strength of the EMF determines the potential difference between the terminals of the source, which in turn dictates the magnitude of the current. So remember, our laboratory activity where we create the simple electric circuit. So the EMF there came from the battery, and yung EMF sumasama doon sa electric current. So ganon yung relationship ng EMF and the electric current. And we also take note that EMF is not a type of force and is a type of energy, and I will discuss it to you further. So despite its name, EMF is not actually a force in the traditional sense of the word. It is a measure of energy per unit charge similar to the electric potential. So the term force is misleading because it implies a mechanical force, whereas EMF is an electrical phenomenon. So in simple explanation, EMF is not a force but a type of energy per unit charge, nag-mislead siya because sa EMF is came from chemical energy, chemical force that converts into electrical energy. So, yun yung misleading concept doon. So, EMF is a type of energy. So, EMF is defined as the work done on a unit charge. So, where E is the electromotive force measured in volts, W is the work done measured in joules, and Q is the charge measured in the coulombs. So, this formula highlights the relationship between EMF, energy, and charge. It emphasizes that EMF represents the amount of energy a source provides per unit charge. So, what is the relationship of electromotive force and potential difference? So, the EMF is closely related to the potential difference across the terminals of the source. So, the potential difference is the energy per unit charge available to the circuit, while the EMF is the total energy per unit charge supplied by the source. Kumbaga, si potential difference is available na siya doon sa circuit, while si EMF is isusupply pa lang doon sa circuit. So, the potential difference is always less than or equal to the EMF because some energy is lost due to the internal resistance of the source. So, example of this is a simple circuit. So, to further differentiate the electromotive force and the potential difference, we have here a table in our presentation. So, you should read it because you can further understand why they are so different. So, in terms of their symbols, magkaiba din sila pero pareho sila ng unit. And their pinagmulan is pareho sila, ay hindi sila magkapareho, but in other way, mayroon din silang mga pagkakapareho. So, just read this table and you will further understand why they are so different from each other. To further understand the relationship of EMF and potential difference, let's watch this short video.
The category of voltage can be split into two subcategories, potential difference and EMF. EMF is acronym for electromotive force, although it isn't actually a force. So what is the difference between EMF and potential difference? Here's a simple circuit with a cell and a light bulb. Let's imagine this to be an electron. Electrons in the circuit go from the negative terminal to the positive terminal. The conventional current goes from the positive side to the negative side. So in this video, we will use the conventional current when we consider the direction of current. A cell or a battery is a store of chemical energy. As an electron travels through the cell gives up a tiny bit of this chemical energy. I'm going to represent this energy using this bit of Lego. You can also think of this electron transferring the chemical energy from the cell along the circuit. The energy transfer from the cell to the electron is from chemical energy to electrical energy. When the electron passes through the light bulb, the electron gives up its energy to the bulb. This energy transfer is from electrical to light and thermal energy. So when we talk about EMF, that is the energy supplied to a unit of charge by a source. And in this process, the energy transfer is from other types of energy into electrical energy. But when we refer to potential difference, that's the energy dissipated by a unit of charge when it goes through a component. So the process of energy transfer here is from electrical energy to other types of energy. So you can think of cells, batteries, and any other power sources as having EMF. But components like resistors, light bulbs, LEDs, and speakers, they will have a potential difference across them.
I hope in the video that I have presented to you, you understand the difference between the potential difference and electromotive force. So when we say electromotive force, it is the conversion of chemical energy into electrical energy. Well, the potential difference, it is the conversion of electrical energy to another type of energy. Now let's move on to the relationship of terminal voltage or VAB with the internal resistance. So when we say terminal voltage, it is a source that the voltage measured across its terminals when a current is flowing through the circuit. This voltage, take note that this voltage is always less than the EMF due to the internal resistance of the source. The internal resistance naman represents the resistance within the source itself, which causes a voltage drop as current flow. So dahil kay internal resistance is yung EMF is yung terminal voltage is nagiging less kesa sa EMF kasi nga meron si internal resistance. So the relationship between EMF, terminal voltage, and internal resistance is given by this equation. So VAB or terminal voltage is equal to EMF minus internal resistance. So this equation shows that the terminal voltage decreases as the current increases due to the voltage drop across the internal resistance. So let's solve a problem with using this formula. So let us solve this problem with the using of potential difference formula. So find the terminal potential difference of a cell when it is connected to a 9 ohm load with cell EMF of 2 volts and resistance or internal resistance of 1 ohms. So in our given, we have the EMF, which is 2 volts, our external resistance, which is 9 ohms, our internal resistance of 1 ohms, and here we have to find the potential difference. But before that, as you can see, wala tayong value ng resistance and ng current. So, all you have to do, kasi nga dalawa yung given ng resistance natin, is you have just to simply add the internal resistance and the external resistance. So our external resistance is 9 ohm plus our internal resistance of 1 ohm. Therefore, we have 10 ohms. So, dahil nga, ang hinahanap muna natin is yung current, kasi sa formula natin dito sa potential difference is kailangan ng current and then ng internal resistance. So, first, i-manipulate natin yung formula ng Ohm's law, which is yung V is equals to current times resistance. So, since may resistance tayo, yung hinahanap natin dito is yung current. So, you have to do is divide both with resistance para matira yung current and i-divide yung voltage and resistance. So, we come up with this solution of E is equals, I or current is equals to 2 volts divided by 10 ohms, and therefore we have 0.2 ampere. Ampere kasi yung unit ng ating current. Take note of that. So, since nahanap na natin yung ating current, we have to use the formula. So, paano tayo nag-apply dito sa formula na to? So, in here, itong part na to, which is yung una, yung E or EMF is equal to VAB plus internal resistance. Yan talaga yung original formula. Pero since ang hinahanap natin dito is potential difference, all you have to do is i-transfer yung EMF and then VAB. So, dito na part is plus sign siya, pero pag i-transfer mo is magiging negative. So, ito yung gagamitin natin na formula. So, all you have to do is substitute all the given in our formula. Our EMF, which is 2 volts, our current, which is 0.2 ampere, na galing dito, and our internal resistance, which is 1 ohms. So, 2V is equals to 0.2 kasi 0.2 times 1. So, 2V minus 0.2 is 1.8 volts. So, that's how to solve this equation using the potential difference formula. You can further explore the concept of EMF by also investigating Faraday's law of induction. So this law describes how changing magnetic fields can induce an EMF in a conductor. So understanding this concept is crucial for understanding how generators and transformers work. And also Ohm's law, which are similar doon sa EMF na equation. So let's solve a problem with using this formula of Faraday's law of induction. So let's solve this sample problem. So what current will be induced in a wire loop with an area of 0.125 square meter and a resistance of 0.013 ohms? If a magnet moves perpendicular to the loop, create a magnetic field that changes steadily 1.25 t in 5 seconds. So in this problem, we have to use the formula of Faraday's law and Ohm's law. So we have our given, which is the n or the number of loops, which is 1 kasi walang nakalagay na number of loops dyan kasi sinabi a wire loop. So our area is 0.125 square meter, our resistance, which is 0.013 ohms, and our changes in magnetic field, which is 1.25 t, and our changes in time, which is 5 seconds. So first is we have to find out our EMF or our voltage kasi sa problem is ang hinahanap is current. So all you have to do is just substitute all the given in our formula. So here is our formula. E or EMF is equals to negative number of loop times area, changes in time divided by changes in magnetic field divided by changes in time. So our n is 1, our area is 0.125 square meter, times our changes in magnetic field, which is 1.25 t, and divided by it on our changes in time, which is 5 seconds. So we have the result of 0.125 volts. So since nahanap na natin yung ating V or yung ating EMF, is isubstitute natin yung mga value dito sa formula na to. Since sa problem natin is current yung hinahanap. So our V or our EMF is equals to 0.325 volts divided by 0.013 ohms. So we have our current, which is 2.40 ampere. So ampere nga kasi what I have said earlier na yung unit ng ating current is ampere. So that's how to solve a problem with the use of Faraday and Ohm's law. Now let's move on to the circuits. So I will explain to you how they work, their essential components, and the importance of safety when dealing with electricity. So imagine a closed loop like a circle where electrons can flow freely. This is the essence of an electric circuit. It is a path created using electrical wires powered by a source like battery, allowing the electrons to travel from a starting point, the source, to its destination. So remember our experiment, which we created a simple circuit. That is an example of this phenomena. So in our simple experiment, it highlights the basic components of an electric circuit. First is the battery. So in our experiment, we used 4 batteries that contain 6 volts because our light bulb it contains 5 volts. So the battery provides the driving force for the electrons, pushing them through the circuit. Next is our light bulb. It acts as a load, consuming the electrical energy and converting it into light and the heat. Next are the wires. The wires act as a conductors, allowing electrons to flow freely through them. And lastly, the switch, a switch that creates a gap in the circuit, allowing us to control the flow of current by opening or closing the circuit. The applications of the circuits are far more complex. While the simple circuit with a light bulb is easy to understand, real-world circuits like those found in televisions are far more complex. They involve multiple components like transistors, capacitors, and integrated circuits, each performing a specific functions. So, do you see this sign? We often see this symbol to understand the dangers of the electricity. So, electricity is a powerful force, and it can be dangerous if not handled properly. The warning signs on electric poles, transformers, and electrical equipment serve as reminders of the potential hazards. So take note of this, why engineers or electrical engineers and electricians come up with this idea to prevent us being electrified. So first is insulation. So electrical wires and sockets are insulated to prevent accidental contact with live wires. So mapapansin natin sa mga wires natin is pag hinahawakan natin is hindi tayo direct nakukuryente kasi nga may mga insulators. Yung mga rubbers, mga ganon. So, voltage. The voltage of a small battery is relatively low as 12 volts, but transformers can generate extremely high voltage up to 11,000 volts, making them extremely dangerous. So, faulty circuits. So, faulty electrical circuits can cause fire. Never use water and use fire extinguishers that designed for these purposes. So, take note of this, class. So, what is the importance of a complete circuit? So, alam natin na yung electric current is nag-flow siya pag kumpleto yung walang interruption doon sa connection ng source para mag-flow yung current. So, any break in this connection will stop the flow of the current. So, this is why it is crucial to handle batteries carefully, never connecting their terminals directly without a load. The rapid chemical reaction within the battery can generate immense energy, potentially causing it to burst. So that's why napapansin natin sa ibang mga applications or mga mga devices na pag sobra yung energy na re-release ng battery is nag-explode or nag-burst, especially sa mga mobile phones natin. As you can see dito sa table natin, sa ating presentation, we have various symbols no, ng ating circuits. So, these symbols help us to visualize kung ano meron sa ating circuits. So, every component in an electric circuit has a specific symbol, which is used to represent it in a circuit diagram. So, these symbols help us understand the function of each component and how they interact within the circuit. So, in our laboratory activity, sinabi dun sa part ng procedure natin na i-draw daw yung simple circuit ng ating experiment. So, we use those symbols like the battery, cells, the load, and the switch para madaling ma-visualize kung ano yung ginawa nating circuit. So, yun nga, yung symbols na to is tulungan tayo ma-understand yung mga function ng each component sa isang circuit. So, in conclusion, electric circuits are the backbone of our modern world, powering everything from our homes to our industries. Understanding the basic principle of circuits, their components, and the importance of safety is essential for everyone. As we explore the world of electricity, remember that it's a powerful force that requires respect and careful handling. Without understanding these circuits, its components, and its laws, we cannot survive in this world we are living, because we are now nag-vary na lang sa electricity. Without electricity, our appliances, lahat ng gadgets natin is hindi na magfa-function. So, ganun yung kalakas yung influence ng electricity. So, that's all in my report. Thank you and have a good day.